Integration with U-Substitution. Now, for some of you on this first one, you may see what to do. You might say, well, I got to increase my exponent by 1. Keep the inside the same. Well, if I increase my exponent by 1, it gives me a 6. I got to have something in front to undo that 6. And then remember, you got to undo the chain rule. The derivative of the inside would be a 2, so you got to have a 1/2 in front to undo your 2. So in other words, you get 1/12 in front. Now, on some problems, you may not be able to see it off the top of your head. You could do what they call U-substitution. We're going to let U represent the inside. So then we're going to go ahead and take the derivative of this. Derivative of U is du. Derivative of the right side would be a 2x dx. Now, you'll notice that in our problem, we have a dx showing up. So we need just a normal dx. We don't want to have that 2 in front. So in other words, you got to get rid of that 2. So multiply both sides by 1/2. So you're now going to go ahead and replace your 2x plus 1, which is our u, with u raised to the 5th. Replace our dx, it's highlighted here, with our 1/2 du. Then pull that 1/2 out in front. And now you'd want to just go ahead and integrate this, which you know would be u to the 6th with a 1/6 in front with that 1/2. And then you want to go ahead and substitute back in what u is. So in other words, that's what we have at this step right here. And then you still get the same answer in the final result. Well, we're going to go ahead and take a look at, well, with this one here, we're going to just go ahead and say, well, let u be the inside. Well, if u's the inside, we take our derivative of both sides. We're going to get a du, the 1 goes to 0, then we're going to get a 2x dx. So you'll notice our du that we have right here of 2x dx, our 2x dx shows up here. So in other words, it's really the integral of the square root of u, because remember, u is this, so it's the square root of u. And then our 2 dx is what our du is. So now all we have to do is just integrate this. So you know you're going to have to increase your exponent by 1. So then you'll have to have a 2/3 in front to undo that exponent, plus c. Then you're going to replace your u with what u was, the 1 plus x squared, to get it back in the same variables that we started out with. Once again, here we're going to use U-substitution. We'll let u be the inside because that's the higher exponent. Typically, you want it to be the higher exponent if you're dealing with just polynomials. And then we end up getting du to be a 3x squared dx. You'll notice we do have this showing up in our problem, but we don't have a 3 showing up. So what you need to do is get rid of that 3. So multiply both sides by a 1/3. So wherever we see the green up here of the x dx, which is what we have here, we'll end up replacing that with our 1/3 du. So we'll have the square root of our u, because u is x cubed plus 9. And then instead of having our x squared dx, we're going to have our 1/3 du. We'll pull that 1/3 in front, and then all we have to do is basically just integrate u to the 1/2. So you know you increase your exponent by 1, got to have a 2/3 in front to offset that, along with that other 1/3 gives you really a 2/9 in front. Replace u with what we started u out to be, and then we end up getting our answer. On the right side over here, you'll notice we have an x squared, a cosine of x squared, and a 3x. Well, I'm going to once again let my u be the higher exponent, so that's x squared. So then du then becomes 2x dx. You'll notice I don't have a 2 up here, I have a 3 instead. Well, to get my 2 to be a 3, I needed to divide both sides by 2, so that's why I'm dividing by 2 here, which would give me a 1x dx over here, and then I need it to be a 3, so then I got to multiply both sides by 3, so that means I get a 3 on top. So I get a 3 halves du. So for this problem, remember any constants you can pull out in front. So I'm going to have this hanging around in my problem, so I'm going to pull that in front of my integral sign. Cosine of a u, because I'm going to have cosine, x squared was my u. My du is my 3x dx. And now, you know when we integrate cosine, we end up getting then sine. So it's going to be sine of u with our 3 halves in front plus c. Substitute in, and then we're done. Here, you could use U-substitution, but hopefully you remember the derivative of something gives you secant squared. Hopefully you remember that that is tangent. But however, since it's just not a normal x afterwards, we got to undo our chain rule. The chain rule would say we'd have to have a 3 hanging around in front, so we got to undo that, so we got to have a 1/3 in front to undo that. Over here on the right, we're going to go ahead and let u be our sine of x. Remember, it's the higher exponent typically. Not always, but typically. Sine of x, while the derivative of the sine of x is cosine of x dx. Well, you'll see that we have this showing up here, and then we have our sine of x showing up here that's cubed. Well, you can pull that 2 in front. We then get a sine of x cubed, cosine dx, which is really a 2. Instead of sine, we're going to go u because u is sine cubed. And then our du instead of the cosine dx. Now all we have to do is increase our exponent by 1. Going to have a 1/4 in front to undo that 4th power. Really gives us a 1/2. So then we have a u to the 4th, or u is really sine x to the 4th plus c. Now the problem here on the left, since we've already integrated this problem, it's now a definite integral. All we have to do is go back to our previous answer after we got when we integrated and evaluate it from 0 to 3. Remember, we're going to want to go ahead and plug in 3. Subtract what you get when you plug in 0. Simplify, and you get your answer.